What if I told you that everything you can see, Earth, the stars, even your own body, makes up only a tiny fraction of the universe? Most of what exists out there is invisible, and what holds it all together might be something mysterious called dark matter. We're surrounded by stars, planets, and galaxies, but according to NASA, ordinary matter, the atoms that make you and me, accounts for only 5% of the universe. The rest, roughly 27%, is dark matter. 68% is dark energy. Dark matter is the invisible skeleton of the cosmos. Without it, galaxies might never have formed. Today, we'll tell the story of this cosmic mystery, where it began, how it evolved, and why it still matters to everything. Let's go back in time. The year is 1933. Swiss astronomer Fritz Zwicky was studying the Coma cluster of galaxies. He noticed something strange. The galaxies were moving too fast enough to fly apart, but they didn't. The visible gravity simply wasn't enough. Zwicky concluded there must be an unseen mass holding them together. He called it dunkle matter, dark matter. For decades, the idea was ignored, just a scientific oddity. Then, in the 1970s, something changed. Astronomer Vera Rubin and her colleague Kent Ford studied how stars move around spiral galaxies. They discovered that stars far from the center were orbiting just as fast as those near it. That shouldn't happen unless something invisible was adding extra gravity. From that point on, the idea of dark matter took off. By the early 1980s, most astronomers believed the universe was filled with invisible mass. At first, scientists thought dark matter might just be dim stars, planets, or black holes. But that couldn't explain everything. Then came a new idea. Dark matter is non-baryonic, meaning it's made of something different from atoms. By the 1990s, cosmologists realized that models of the universe only worked if they included a kind of slow-moving, invisible matter called cold dark matter. This became known as the lambda CDM model, lambda for dark energy, CDM for cold dark matter. It's now the standard model of cosmology, and it tells us the universe is 5% normal matter, 27% dark matter, and 68% dark energy. The search for dark matter also moved from astronomy into particle physics. Scientists began hunting for new particles, WIMPs, weakly interacting massive particles, and others like ixions. From a strange anomaly, dark matter became the key to understanding how galaxies form and one of the greatest frontiers in science. But why does this matter to you? Because without dark matter, we might not exist. It's the invisible glue that allowed galaxies to form that helped shape stars, planets, and eventually life itself. It's not just a scientific curiosity, it's the framework of everything we see. Culturally, the idea of an unseen force shaping the universe has inspired movies, books, and art. It's become a metaphor for all the hidden forces in our world. And scientifically, it drives some of the most advanced experiments ever built: space telescopes, underground detectors, and international collaborations. One of the strongest pieces of evidence for dark matter comes from the Bullet Cluster, to galaxies that collided. Images show the ordinary matter separating from the dark matter, proving they behave differently. Now, here are a few surprising facts. First, dark matter isn't called dark because it's black. It's dark because it doesn't emit, reflect, or absorb light. It's completely invisible. Second, almost a century after Zwicky's discovery, we still don't know what it is. Decades of searching, and no direct detection yet. Third, some experiments looking for dark matter are hidden, deep underground, more than a kilometer below the surface, to shield them from cosmic rays. Like the LUX experiment in the United States, where scientists watched tanks of liquid xenon, hoping to catch a single collision between a dark matter particle and an atom. Nothing so far. But every experiment gets us closer to the truth. From Zwicky's missing mass in the 1930s to Vera Rubin's galaxy rotations, to today's massive detectors deep below the Earth, the search for dark matter is one of humanity's greatest adventures. It reminds us that the universe is mostly unknown, that what truly shapes everything we see is something we cannot yet perceive. Dark matter is the hidden framework of reality. Understanding it could reveal new particles, new forces, and maybe even a new chapter in physics itself. So the next time you look up at the night sky, remember, 95% of what's out there is invisible to your eyes, but it's there, holding the universe together. Which mystery should we explore next? Let us know in the comments. And don't forget to like and follow for more stories from the hidden side of the universe.